Today, we are going to be talking about a method that myself and a couple of other colleagues have been iterating on for a number of years, and we finally got around to figuring out a name for it, and we call it packed bus. And yeah, it's going to help us proactively deal with cybersecurity threats in our architecture. So throughout this talk, we're going to talk a little bit about model-based systems engineering, what it is, what it isn't. We're also going to talk about and hopefully answer the question of, can I just use a whiteboard to model and hunt threats within my system? We're going to talk about security analysis throughout kind of like the system's lifecycle, and then narrow in specifically on threat modeling, kind of that subset. And then finally, give you a step-by-step of the process that we've kind of been piloting for doing this. So model-based systems engineering, right? Sometimes it is easier to talk about what things aren't rather than what they are. So when we're talking about MBSE, a lot of people think it's a bunch of diagrams. It's a very expensive tool suite that you have to buy that has a very hard learning curve, right? But it's not just about diagrams. It's not about the tools that you use, right? It's a process, it's executable models, and really it's a shift away from working in documents, making manual updates, to having a model that allows you to perform analysis on it rather than doing that analysis in PowerPoint, right? And so that question about, can I analyze my system with a whiteboard diagram? Can I hunt for threats using a whiteboard, right? So if you want to just convey an idea, right, you can sketch something. Helps if you're, say, describing a particular algorithm or like in this case, right, giving a PowerPoint presentation, that's fine. However, once you want to start communicating more complex ideas, right, that's where we start getting into diagrammings and more formal diagramming languages. So UML, SysML, right, we start to have these formal constructs that allow us to communicate those ideas more easily. However, once we get all the way over to needing to perform analysis, right, that's where we need that digital environment that you hear so much about in MBSE presentations, right? That is going to allow us to actually analyze those different diagrams and extract more information out of them than hopefully what we have to put into them. And so, again, just driving home that point about complexity, right? On the right side of the presentation here, you'll see a graph of the amount of software that is in our aircraft, right? So we heard a little bit about that from one of the folks that makes the engines that power these things. There's a lot of other stuff in those systems as well, right? Avionics, electronics, especially when you're talking about military aircraft, right? Radars, things like that. Additionally, some other work that my colleagues have done is to model the DevSecOps process. So that's the diagram that you see on the left. It's actually fairly complex. Those nice little pipeline diagrams that you see in GitLab whenever you are building and deploying your code, it's not quite that simple. This is kind of one of the views of the flow of what a DevSecOps process might actually look like, right? And so when we're talking about these complex systems, it's insufficient to just use PowerPoint, Visio, a diagramming tool, right? This is going to be the domain where we need a model. And so you're going to hear me use that term model a lot, right? And so what do I actually mean by a MBSE model? So this is going to be a model that is executable. We can run simulations. We can gather data from it, right? It's going to have a modeling language. We're going to talk about kind of the, I'll say, preference that I have as far as a modeling language and framework. It's also going to be a digital environment. So again, that's going to be your tool, but again, the tool is not the sum total of MBSE. And then finally, going to be an architecture or a design process. And so I am going to talk about two of these four. We're going to talk about, like I said, our architecture and design process that we have for identifying and mitigating threats. And then we're also going to talk a little bit about the modeling language, specifically UAF modeling language and some of the extensions that we have added to it. So I'm not going to give you the whole picture. I'm not going to hand you MBSE as a whole, but hopefully a couple of pieces. So I mentioned that we're going to talk about threat modeling, but threat modeling is kind of a subset of this larger security analysis piece that should pervade most of the steps of your systems engineering lifecycle, right? So most of the stuff that we're going to be talking about is in the do this column, right? We're going to be doing our threat modeling. However, you'll see even starting from requirements, right? You should be looking at things like security requirements, what regulations, right? If you work in defense, if you work in banking, right? Heavily regulated industries, those are probably going to bring along a lot of security requirements just based on the nature of your business. As I mentioned, we're going to talk about threat modeling against your architecture. This is going to involve your architecture models, right? This is just slightly before design, before you might start making those design decisions, right? And so we're going to talk about how you can abstract some of that more specific threat mindset up to that architecture level. And then on through your detailed design and DevSecOps, we'll talk about how our process here is more geared towards the architecture side of things and how there might be some better tools that would help you in the design or DevSecOps phases. All right. So whenever we talk about threat modeling, we're really looking to answer four kind of key questions. First thing is, what are we building, right? So that's going to be the model of your system. The second one is what can go wrong, right? So if you're more familiar with safety, these would be like your hazard cases. In this presentation, we're going to call them threat scenarios. The third one is what can we do about those threat scenarios? What can we do about those wrongs, right? So these are going to be your security controls. We're going to show how you can source these from a lot of great open standards like NIST 853 and some others. And then finally, right, that verification validation step. Did we do a good enough job of threat modeling, and how can we prove that? And so that's where we're going to get into that analysis of the model. So as I mentioned, we've been kind of piloting this method that we've called packed bus. So it's an architecture evaluation method based on UAF, which is the Unified Architecture Framework, and STRIDE, which is a threat modeling methodology. We'll kind of dive into both of those, but essentially the sum total here is that this packed bus method, right, is going to combine a threat modeling method along with an architecture framework. It's going to help guide identifying, analyzing, and then eventually mitigating threats against your system. So it's going to give us some guide rails, some guidance on how to do that. So luckily, I don't have to harp on this slide too much because Greg earlier talked a little bit about UAF. But the key here is UAF is an architecture framework. So it's going to prescribe different types of models that you're going to build, different views for those models, right? So it's built on top of UML, SysML. So for those that are software engineers, you probably use a little bit of UML in your time. It's also based on DODAF, MODAF, and NAF. So if you've ever created an OV1 in PowerPoint, right, that's that's kind of DODAF, right? But it's going to extend beyond that a little bit. Stride is a threat modeling methodology, and pretty mature. It's been around since the late 90s, originally developed at Microsoft. And it's pretty simple in its name. It's a mnemonic, right, that talks about the different effects or types of threats that you might see. So things like spoofing, tampering, repudiation, or non-repudiation, right? However, the thing I think that a lot of people miss with Stride is they think it's just a mnemonic, right? But it's a little bit more than that. If you dig into some of the literature by Microsoft and other folks, Adam Shostak has a really good book on Stride, right? It does provide guidance on how to apply it, some of the different ways that you can take this mnemonic and use it to analyze your system, right? And one addition that we've added to Stride is that final S, which is scarcity of process, right? So things that just aren't happening that should be, right? So security checks or continuous monitoring that should be happening, it's written in policy, right? But it's not actually going on. So whenever we're talking about threat modeling methods, they're all really just tools in a toolbox. So I've got a whole bunch of threat modeling methods listed here. So you'll see Stride up top. The order does not imply anything. It's just a big old list. But again, with tools in your toolbox, different tools are going to be applicable at different times. For our purposes, Stride is going to be particularly applicable in the early stages of systems engineering. So your concept of operations, whenever you're defining your architecture and requirements, right? So that's mainly where we're going to be focused. If you already have a system that's in the operations and maintenance phase, and let's say it's an IT system, right? Octave, third from the bottom, is going to be a much more applicable tool, right? Let's say your system is in the system implementation phase and you've done your modeling well, right? And you have state machine diagrams for your entire system state. Attack trees are probably going to be a bit better, right? You're going to be able to follow through those state machine diagrams and see how an attacker is going to progress through the system, right? But again, what we're going to be focused on is this concept of operations and architecture requirements portion. We heard earlier, right, how we want to shift left all of that security engineering that we can. And so we'll talk about how Stride, I think particularly, is capable in that early system development area where some of these other methods you might lack the information to apply them. So UAF has a variety of model kinds and views. One of those is the operational. And so this is going to be slightly more detailed than, say, your business case or your concept of operations. It's going to start to get into who are your performers? So who or what is doing a particular function? What information are they providing? So we're mainly going to be focused on this operational view of the system. And whenever we're modeling, right, with this packed bus method, there are kind of four key model views that you need to prepare to be able to threat model against. The first is going to be your operational taxonomy. That is going to provide sort of the structure of your system at the operational level, who is going to be performing what functions. The operational connectivity, this is going to be your data and information flows between components. So very high level, you're not going to know necessarily design specifics or specific implementations, right? But you do know, say that, component A needs to talk to component B and convey this type of information, right? You just don't know the protocol. operational processes. So these are going to be your sequence diagrams, right? How is a particular mission carried out, or how is a particular business case handled? What information needs to flow at what time between your different system elements? And then finally, we need to catalog our personnel taxonomy, right? So this is going to be not only the people, say like your software engineers or your DevOps engineers that are going to be carrying out certain processes, but especially important for threat modeling, right, is you're going to be your threat actors, your insider threats, all of those fun unnamed people that we heard about in the last presentation. So once you have your model generated, the next step is to start to apply Stride to those various model views that we talked about, right? So Stride has kind of two variants. The first is per element, right? So for each element in your system, all of your operational performers, right? You want to apply Stride to those, identify how could this particular performer be spoofed, how could a particular database be tampered with, right? Next, Stride also has a per interaction element. So this is where the interaction and process diagrams come in. So for each interaction, for each data flow between your elements, right, we can apply Stride to that particular data flow and identify things like how could an adversary deny or perform a denial of service on this particular connection, right? And one of the things that we found is that if you structure your threat scenarios in kind of a normal pattern, it helps with analysis later on down the line. So we give you this nice little Mad Libs kind of scenario cheat sheet, right? So you fill in all of your different actors, your actions that they take, or a particular attack that they use, right, against an asset, and the objective that they want to achieve. And so the example here, right, an advanced persistent threat performs denial of service to disrupt the SIEM, so your security incident event monitoring solution, and insert malware during that outage, right? So that is kind of our standard scenario template. And again, we generate kind of those attacks and actions based on Stride. So bringing it all together into the model, we want to generate the security taxonomy views that are going to represent all of the connections between all of our system elements for a particular threat scenario. So a lot of boxes up here, but we'll start kind of in the center with that kind of teal box, disrupted monitoring, right? So disrupted monitoring, that box is going to capture all of our threat scenario information. So you'll see the text, again, captures that common template that we just walked through. And then key, we're going to take all of the interactions between our different system elements that are kind of resident in that text and make them explicit within the model, right? So here in the text, we say a threat actor, but what we want to do is tie that to a specific threat actor model element, right? So over here, we have our advanced persistent threat, we have our insider threat, right? So this helps you start to think about who has the capability to cause a particular threat scenario to manifest, right? Sometimes it could be just anyone off the street. If you don't do any sort of safeguarding of your SQL input, right? Someone could just paste it into a search box and they gotcha. Other times it's a nation state actor that's crafting like a specific bespoke 0-day capability, right? So we want to start thinking about who could actually cause that scenario. Next up, if we go up into the middle of the diagram, we see that compromises relationship. This is where we're going to identify what activity does our system do that this threat scenario is going to affect, right? So if we have a website and our threat scenario is that a threat actor is causing a denial of service on our website, right? That's probably going to affect the activity of serving the website. And so we want to identify any and all activities that our system needs to perform that are going to be compromised by a particular scenario. We'll get into it later, but each of those activities should trace to a requirement, and we can then also map security controls that are going to mitigate those threats, right? So that's most of everything in this diagram. I know it's a lot, but we'll have a couple more examples. So I mentioned that we base our process off of UAF and the UAF modeling language. If anyone is very familiar with that standard, you probably saw a couple of relationships that are not in UAF on that last slide. So to adequately capture all of the information that we needed to do threat modeling, we had to extend UAF slightly. So Greg talked about a custom profile earlier, right? It's very similar. Here, outlined in red are all of the elements that we added. So things like security requirements, our threat object that's going to capture our scenario, right? Attacks, which we'll talk about a little bit later. Those are going to be ways that a threat could actually realize that scenario. And then all of the various relationships between our new threat object and the activities, processes, components, or information that threat scenario could affect. So I mentioned attacks, right? So one of the criticisms of not just Stride, but many threat modeling methods is that you need to be a subject matter expert to be able to identify weaknesses to a system or how a threat actor might go about attacking it, right? So one of the great things that has come up in the last several years are prevalence of open matrices and frameworks like Attack, Capec, others that collect and in a kind of community-driven way identify these attacker TTPs. And as someone that's not intimately familiar with how, say, like a hacker thinks, you can use these matrices to identify different ways that someone might attack a system. What we've done is within our MBSE model is imported a couple of these different frameworks that allow us to not only use them to iterate on our threat scenarios and our generation through Stride, but also substantiate those threat scenarios and claims, right? So whenever we're modeling and we're hunting for threats, at the end of the day, we have to implement some sort of mitigation to control that threat, right? Unless we just accept it, which most of the times it's hard to convince people to just accept that a threat is going to affect their system. And so those security controls are often going to cause your system to be more expensive or more complex, right? And so whenever we are threat modeling, we need to make sure that we're not just dreaming up threat scenarios that couldn't happen, right? We want to tie to those specific TTPs, those specific threat actors, so we can substantiate the claims that we're making in our threat model and eventually, substantiate the cost and complexity increases that some of these security controls are going to cause. So as I mentioned, a couple examples of good databases for threat TCPs are Attack, Capec, and if you're in the space domain, Sparta as well. And then additionally, security controls, so how we're going to mitigate those threats, right? We can import elements for things like defend, or I mentioned earlier, NIST 853. So kind of got all these in there, and through our threat modeling profile, we can link those security controls in. So step 5, right, is the analysis. So this is where I kind of mentioned earlier how you could do most of everything up till this point with diagrams. In fact, I've been showing you diagrams that prove that you could probably just draw this out on a whiteboard, right? However, whenever we get to the analysis stage, this is where we really start to reap benefits of a model, because we start to extract information that we generated through those security taxonomy diagrams, and we're able to tell, hey, did we actually do a good job threat modeling, right? So within Pact Bus, we have kind of a standard set of matrices that we use. So for example, on the right here, you can see a matrix that shows the dependency between our operational processes and our requirements, right? So if we want to fill requirement X, we need to perform process Y, right? And those arrows in the boxes show the linkage between them. So you can see that there are some requirements that require an extraordinary number of processes to happen to fulfill that requirement. Those are going to be your higher level ones, right? However, you can also see that there are particular processes that fulfill many requirements. So you might consider those processes to be critical, right? So we can start to look at, okay, what processes do I need to pay more attention to in my system? Additionally, for other matrices that are useful, right, you can look at similar dependency matrices between your operational activities and threats. So you can imagine a set of requirements across the top of this matrix, right? We have all of the threats that we've registered. And if we see that there are a large number of threats that affect a singular process, right? Well, all of a sudden we need to probably pay more attention to that process, probably invest a little bit more in securing the implementation of that, right? However, if we also see one threat that affects a ton of processes within our system, we additionally probably need to spend a little bit more time really understanding that threat, making sure that we're actually applying mitigations for it. So in summary, right, MBSE, not just about diagrams, and it is definitely an evolution away from document-based processes. But as I kind of showed with that analysis portion, right, once you start to actually generate some of those analyses out of the model, that's where it starts to benefit you more than all of the work that you put into modeling your system. So being able to integrate MBSE and threat modeling, right, again, just enables that analysis beyond just whiteboarding or pointing at particular elements in a diagram. And additionally, through the inclusion of things like attack, CPEC, other matrices into your MBSE model, right, it opens the door to threat modeling, not just by subject matter experts, but your systems engineers, other engineers that maybe don't have that subject matter expertise, but they can follow kind of this process and draw from those matrices, those kind of community standards, and hopefully make your system more secure. So got a couple of resources. I think these slides will be available eventually. So if you want to check those out, but thank you guys for time and open to questions.
Hi. So something I've been looking at is using MBSE paired with large language models and other stuff to take the requirements and generate code and architectures based off of MBSE. Have you looked at ways to either leverage those to generate potential attacks or verify that when the system is actually being developed, that you are satisfying those original security requirements with AI and other kind of models based off of that. I'm kind of curious.
Yeah, that's an interesting thought. We have not looked at integrating any sort of AI into this process. I will say that is more generally just model integration with other tools is kind of an area of interest, right? So we talked about execution and the executability of your models. A lot of times you'll have other, say, simulation environments that you might want to model, say like a physical system in or something. And so being able to connect those to your MBSE model, it's definitely something that I'm interested in, and I think we want to look at. But the AI piece, haven't really thought about that.
Are there any kind of models or syntax like SysML version 2 that you find easier to work with or more extensible across different platforms and integrating with other tools?
Sure. So I am very excited by SysML v2 and having just a text-based standard because, interoperability between tools is generally limited, right? However, I think we're still waiting for a fully fledged tool to implement, say, like SysML v2. But I think that will, definitely provide or should provide better interoperability between the different tools.
Yeah, and that's kind of where we've, at least our investigation of it, we've leveraging things that are proprietary, make it much harder to bring large language models into the mix. So we're very interested in SysML v2 as well for those reasons.
Yep. Yeah, agreed. Again, just the portability of the model, if you're solely text-based versus, like you said, a proprietary format, is definitely something I'd be looking forward to.
Hi, thanks. My question's about the additional S added on strides. Can you talk a little bit more or give some more examples about the scarcity of process?
Sure. Yeah. So a scarce process, something that should be happening but isn't. So, for example, I think primary one that drove it for me is something like a code review, right? So whenever you say want to merge code in your tool of choice, GitHub, GitLab, whatever, generally you'll have a gate where someone has to click an approve button, and sometimes you might have very formal like review processes for that code. I've also worked in places where people will blindly click that button, right? And so even if you have a documented process that might be resonant, say, in your model, you might have an operational activity that says like, security review of code. It might not actually get implemented whenever it comes to, okay, I've written code, I've got a merge request out, right? Someone might just click like approve. So that's, I think, a really good example of a process that is documented but just isn't actually implemented.
All right, let's thank our speaker, Alex, one more time. Thanks.